So hi everyone, I'm Noah Macover and this is Verge Khan and we're Primitive Labs and we're a research and design organization with the mission to reshape the way we think, make, and interact with organic systems. We've been working on Organic Primitives, which is a tool set of interactive bioplastic. We've been working on this project for the last several years. It was first started in the academic space at MIT and the work was published at CHI and won the Best Paper Award. And now we're continuing to forward this work at Stochastic Labs, which is an art science residency in Berkeley, California. And we're working to build out this work to be accessible for makers and creators like you to design interactive experiences with organic systems. In this talk, we'll introduce our library of color, odor, and form-changing bioplastics and examples of different interactive projects that utilize these materials. With these tools, you can use natural inputs beyond electricity, like liquids, to activate changes because signals in the chemical and biological world are mediated through the flow of liquids and fluids. And you can also design multisensory outputs in a compact and integrated way. And finally, create interactive experiences in new application spaces. So we'll start by talking about our motivations for the work and share with you what we've developed. We've brought some samples with us, as you see in front of you, so you can experience these materials yourselves. And we want this talk to be interactive, so if at any point you have any questions, thoughts, feel free to call out and let us know. Oh, it quit.
No.
Thank you. Oh, we're still dealing with digital tech. Primitive.
Yeah.
Yes.
Okay. But essentially, kind of talking about the motivations, why we started doing this was with this question of why we started out with this question of why is it so hard for us to actually engage in a sustainable way with the world? Like, why is it that every day when I'm packaging up some broccoli, it's so hard and I have to think about it, and why do I have to constantly confront that I'm using plastic, essentially? So, and objects in the material world, they surround us and they have a longer lifespan than their actual use. So when I buy a plastic bag, these bags last for more than 500 years, 1,000 years, and there's no other. Why is it so hard for us to have a different solution right now?
Yeah. So actually, if our consumption patterns continue, there'll be more plastic mass than fish in the oceans by 2050, which is really shocking. And as the climate crisis becomes more grim and more apparent to all of us, we need to build alternatives to our design systems and design in accord with nature. We need to design objects that have life cycles that reflect their use. And recycling isn't enough, it just delays the inevitable. Plastic objects still eventually end up as trash. And people are working on alternatives to these waste streams, and we're excited to be a part of imagining new possibilities. Nature has designed immensely complex displays of information in multisensory dimensions. For example, vibrant colors of fall foliage signal the changing of seasons. Chemical engineers have used molecules from nature, such as menthol, to signal cleanliness in household products. The potential of integrating natural materials to create multisensory experiences hasn't been fully explored. While sensory interactions are abundant in natural systems, they are seldom utilized by makers and designers due to the lack of inaccessible tools, or the lack of accessible tools for integrating them into practice. We believe that it's possible to create sustainable and interactive experiences.
And there have been groups working on developing more accessible tools that integrate with nature and bioengineering. For example, BioBricks is a standardized logical parts that aid people in doing more genetic engineering and making that synthetic biology accessible. However, these tools still require special facilities, and the different objects within the waste systems aren't really addressed in this approach. So our work builds upon and forwards what they're doing, but we're really thinking about human scale interactions and people's interactions with everyday objects, and how do we create more sustainable waste streams.
So we want to work with all of you on your projects to create accessible, easy, and usable tools to interface with natural systems.
So I'm introducing Organic Primitives. So this is the project, as Noah mentioned earlier, that we've been working at for around like 4 years now, 4 to 5 years. And it's essentially a library of smart bioplastics that can be developed into different form factors that can change color, odor, shape, maybe even all three of them together. So you see here that this material is curling up. It is also changing color. Next slide, please. And again, as Noah mentioned earlier, signals in the biological chemical world are mediated through the flow of fluids. And whether it's contextual fluids such as the rain or raindrops and ocean water and human tears, we can use all these inputs to make these properties change. We could also have more control over the system by using prepared inputs, which you'll actually see on your desk. You have a dropper that has prepared inputs, which is citric acid, and then you also have natural input, which is lemon. So this is an example of how it works. So you have a fluid input that is interacting with the material that is tattooed on this apple, and on this, which then triggers this change. Spotted pattern emerges, which communicates to you that it's toxic, potentially, that maybe it's been contaminated by during transport. So this is one example of how these materials can be integrated into objects to provide information to people in the world. Next slide. So now I'm going to kind of have you guys try it yourself. So you have your lemon in front of you, and you also have a dropper. I'd encourage you to dip the lemon and draw or pattern the material in front of you, and then just watch it change. Oh, yeah. You can either squeeze it or
You can use your finger.
you can pattern it, draw it on. You can also, after you do that, take the dropper and drop a small droplet onto your material.
Oh. What exactly are the properties of the plastic?
So, what was your name? Anika. Thanks for your question, Anika. Anika was asking, what are the specific properties of the material? So these are different bioplastics, biopolymers that are. These are different biopolymers, bioplastics that are derived from natural sources. This one in particular is sodium alginate, so it's seaweed-based. And we've doped them with different organic compounds that are able to create these color changes.
There isn't any dioxin in it.
Nope, no dioxins. Yeah, so I see that a lot of you guys have already tried to paint on some lemon on the plastic, so why don't you also give it a shot to put a droplet of the liquid in front of you onto it. Yeah, it's very similar. They're two of the same thing, essentially.
What's the liquid?
So this liquid is citric acid.
Oh.
It's the prepared solution version of the lemon. And it can give you a little bit more control in terms of like patterning it and placing it on and creating these different patterns.
This change is permanent, or it's going to kind of go back to the original?
Yeah, so your question was if this is reversible, essentially. The mechanism itself is reversible, and there's a lot of different, so we've tested this actually. We ran different studies to study the range and the reversibility, and also we haven't done time scale yet, but that is definitely our next study. And they are reversible. However, it's up to a certain amount. So there's up to a certain amount of uses that this is possible, which is actually kind of reflects our main point. A lot of the like interactive objects that we create today, they don't really, the life cycle of them don't reflect their use. So how do we create very controlled, repeatable devices and materials that can be integrated into objects that reflect their use, that after a certain amount of uses, you don't need them anymore. A plastic bag doesn't need to be, packaging material doesn't need to be lasting 1,000 years in the landfill. So, yeah. So basically, you guys just experienced the color changing primitive. And we actually have other primitives that we have created and also tested on users. And one of the main things that we optimize for that I think is different from traditional engineering materials practices is this idea of human readability. Are these changes in a human readable timescale? So we developed these an odor primitive and a shape-changing primitive that all reflect the changes within a human timescale.
So that wasn't fast forward.
That was, those particular videos were, because those are in a matter of seconds. So when you just experienced it, it was around 20-second change. This is like a 5-second change. So in this so you can do actually a lot of different things. We've explored this area to create many different combinations and to build more complex interactions with these. So you guys experience a material primitive, which is just property change. But the next sort of level is creating multimodal composites where you can have one material that changes multiple properties. The third is you can also create another layer of complexity, which is integrating them into different form factors, such as from fibers to molded forms to films and sheets. And finally, there's the fourth column, which is functional mechanisms. Using fluidic logic, we can make, for example, a device that tells time because we know the diffusion rate, or a mechanism that creates multiple outputs of color through just 2 inputs.
So these are all different types of plastics, and then, okay, different types of plastics and different types of liquid put on top, or same plastic, but then depending on the material you put on top, it shows different properties.
The properties are, the different primitives are using different materials, and it has inherently different composition. Primarily because we're trying to optimize for those changes independently, but actually all of these primitives can be combined together. So you can make like a single material. I hope I answered your question. Yeah. Okay. Yeah. So yeah, and as you kind of got a little bit of experience, it's kind of hard to control very specific outputs with just the lemon. However, it's possible. But there are different ways of, I guess, creating those outputs. One way through a dropper is like in a discrete input, which allows you to tailor very specific locations that make it change in very specific ways, or local input where you can have a stream of fluid that goes through it, or global where you just spray it on and you activate the entire thing. And we can also print these materials. We've built a bio extruder, essentially, that allows us to create different patterns and print them. And we can also activate them in different ways, too. One of the major aspects of this is trying to make this accessible. So actually, I want to kind of get your guys' input about this. Like, what are the best tools that we can, and the best way to integrate this into practice that allows you guys to make it more accessible for you guys to use? Is it a software platform? Is it more like on a kit level? Is it more a web-based like forum? Like, what is the best sort of way to integrate this? Because one of the aspects is we're trying to make it really accessible and human readable and make it combinable. And those are our first steps into making it accessible. But I think there's more that we need to do in order to do that, to make that possible. Just to kind of show you guys some of the possibilities of new interactions that can emerge through these materials. For example, this is one interaction. You can interact with plants, make them change color. That's one. Or make temporary tattoos that can also display different information. Or because these are all edible bioplastics and degrade, you can eat them and make shape-changing pasta. Or make an umbrella that bleeds in the presence of acid rain to tell you, ouch, the sky is hurting, something needs to change. Or a shirt that displays different patterns every time you use a new perfume. or an apple that displays information that it's been contaminated during transport, or a compostable fork that just breaks down because you're done using it. So those are some examples of potential projects, and this is sort of like our approach. There's a semiotics layer on top of it that allows us to create a new language, essentially, through these patterns that are derived from nature. So for example, you understand when someone is bleeding, that there's pain. And you also understand this sign, or the toxic mushroom, because it's well known. It's actually referenced in Mario, in different games. So you can also use this as a signal, like sign or a symbol, to integrate them into everyday objects to make changes. And some new areas of application that I think interactivity hasn't been integrated into, like in a very robust way, is including food, the interacting with the environment, or interacting with their health. So those are some areas I think that this work opens up. Yeah, and we, again, like, really want to invite you to give us input on what is the most interesting aspect of this work. Like, how do you see this potentially coming into fruition, maybe even for you guys to work with? And yeah, and we have a survey, so we would really appreciate it if you could fill it out. Thank you. Yes.
I'm curious to know how you tattooed or integrated this material onto the shirt and apple.
Yeah. So this is so the question was how were the different materials integrated onto some of the applications, like the apple and the shirt. So that's through a different form factor. The form factor being you starting with a liquid form, and then patterning it on. So there's just different form factors that allow you. Or in the case of a shirt, you can make different textiles from extruding into a fiber.
Oh yeah, because you can integrate fibers into.
Yeah, exactly. And then you can sew it onto the material. Yeah. Yeah, thanks for that question. There's lots of materials that can change. Oh, okay, so the question is, have these materials been used in industry? So there are many, many materials that change properties in our world. And specifically, we're focusing on plastics. Actually, everything in our world changes properties to some degree. But not in the controlled fashion that I think makes it, I guess, like, palpable for people to actually use. So this is what we're trying to do, is trying to make it really controlled, and also specifically focusing on plastics.
The main thing of this kind of materials is biodegradable.
Yeah, it's biodegradable plastic that is interactive, that can change properties.
What do you guys think about making, like, say, a nail polish?
Nail polish?
Color, you drop some liquid and it changes to red tomorrow.
Yeah.
Oh, similar to the date rape
Oh, yeah.
one, where it changes color into like the green. It has some drug in it.
Yeah. Yeah, there's definitely many, many different applications that are possible. I think one thing is that we're more interested in developing a platform to enable other people to create those applications. And those are certainly, like, really great ideas. Yeah, and I think our question is really, what form does that take? And trying to identify our audience more clearly, and creating tools that really allow people to feel empowered to make stuff with it. Yeah.
I'm wondering what kind of environments would be especially beneficial to use this changeable.
Yeah.
Yeah, like if I want to make a dress, I'll use y'all make a nail polish. How, in what environment can I actually get much change?
Yeah, so I think this goes back to how much control that you want. Actually, we have a slide in the appendix that maybe this might be a good time to show.
That I don't expect to ever experience acid rain, for example.
The video of the machine. Well, oh, here it is. So this is one sort of example of integrating it in, is sort of having a machine mediate this process and having it more controlled so that it's actually not the environment purely triggering it. That is one possibility. But that's like one way, if you want a lot of control, is you have it mediated through electronics. But if you want to have an environmental change, there are different ways of, for us, we're trying to create different primitives that allow for that, that change. Whether it's like integrating packs of fluids that then sort of pop, or they get activated through like a physical mechanism, or again, you can use, maybe it's not acid rain specifically, it might be just the rain, but because the material is, the primitive is composited in such a way that it will activate the changes that you want. So that's also part of the reason why we're really interested in building out this library of like large, more primitives, so that these new interactions are possible.
So, for example, like the dream will be some kind of, I'm thinking about like the container for the laundry detergent. So it has some inner layer that with the detergent it's rigid and keep it inside, but let's say once I finish, I put water in it, and the water activates a process that makes the plastic go into kind of
Yeah,
disappear and melt into the drain.
yeah, that's a,
Thank you. So the question is whether the vision is having kind of materials that coat industrial form materials like a dishwasher detergent and then can disintegrate after the use. And yeah, that's a really great question. I mean, we're thinking and moving into spaces of thinking, how do we engineer entire systems that work in this way? So what's the flow of production to use to then how does it disintegrate? And I think these materials are really a way to go into that system, and that's one of the visions that I think we're excited by.
yeah. Yeah, and I think the question becomes, how do we, because plastic is everywhere, and obviously it's very useful, and we love plastic, but it's not a very sustainable solution. Can we have an alternative bioplastic solution that's not just performs better or in different contexts, or it's able to be manufactured, but it's actually inherently interactive, or it gives you this other layer of value in the experience. So maybe, for example, in the example that you mentioned with detergents, it could degrade by itself because it knows it's empty and there's no, the mass or the fluid content within there is, it degrades.
Oxygen, for example.
Oxygen
There's
could be,
no fluid inside, so
Yep.
it's
or it could be through human interaction, like the handle activates it in some way, activates a fluidic mechanism internally. It could be, there could be many, many different ways to actually make that possible. And I think one of the major reasons why we're interested in kind of like bringing this out to people is I think we can't do this alone. And we can't also, I don't think one application can really solve the entire issue. So,
So you essentially want to make something like an Arduino kit with all kinds of electronic sensors components, but it's biological, like a soft counterpart of the Arduino kit.
yeah,
The-
essentially.
Yeah, the question was whether our vision is kind of a soft biological Arduino kit. And yeah, we've definitely talked about that, thought about that, and are really excited by the potential of the kind of more sophisticated interactions and logical systems that can happen with biological and chemical interfaces. But first, we're also thinking we need to build out a base of people who are familiar and can help develop and start to, tailor, and like the BioBricks is doing, they're getting way more people to become creators of new genetic sequences. So we want to see, okay, what are the logical mechanisms? How can we start standardizing them? interacting with them, and then getting people using them, wanting to come up with projects, like some of the brilliant ones that were just mentioned, and then we'll keep building out those tools and eventually try to develop something that is really quite sophisticated, like an Arduino.
Yeah. You had a question? Sorry, could you
Can you speak?
repeat? Say again. The edible plastics that we're mentioning, is there a name for it?
Molecular name?
Is there a molecular name for it? So each of the different materials that we showed, the color changing primitive, the odor changing primitive, and the shape changing primitive, they all have different base biopolymers and these biopolymers are edible. You see them in food. And they're, for example, alginates it's a seaweed, it's an algae. It has many different properties. So one of them is we can make bioplastics from them. In terms of a name, we're calling it a color primitive and an odor primitive just for the purpose of what we're trying to do. But they're actually made of many, many different molecules. So there's not one name, I guess, for it. What's that? Yeah.
Are they extracted from algae?
Yeah. Yep.
Yes. Some of them, yeah.
Some
And
of
I
them.
mean, part of the library we're hoping to build out is examining kind of all. There are other people, like the Biomimicry Institute's trying to create a whole list of different kinds of natural materials that have different properties. So part of that's furthering research and saying what else has interesting properties that are evolved and continuing to characterize them and build out procedures around them. So we've done a lot of really specific tailoring and scientific level research to characterize beginning some of those properties, but there's so many more. And also with synthetic biology, some of those properties will continue to be tailored. We'll start seeing proteins outside of cells that can help us generate new materials with new properties. So as that space continues to build, this work, I think, will interface with it in really sophisticated ways.
Yeah.
So I just have a one. If we have access to this edible plastic, what is preventing us from using it at a mass scale? Like say just for like water bottles, or for there are so many day-to-day plastic needs that even we have to use these materials. If somebody starts doing they should market it.
Yeah.
So is mass scale a problem?
So I think so the question was, if these edible plastics exist, why aren't they ubiquitous in everyday world? Why aren't we using it in plastic bottles? I think this is a multifold, very complex question because there's an economic component to the petroleum industry. There's like lobbyists in that space that actively advocate for plastic. So that's one piece of the puzzle and of the issue. The other piece of the issue is, I think the infrastructure around composting bioplastics is still at its nascency. We're still in research realm. So I think there's a lot of work to be done also in this. How do we create an economy and an ecosystem around the post-use of these objects? And there's an infrastructure issue at hand. And I think for us, we're actively thinking about that and actively considering like what's in this kit. Does the kit include a trash can that actually degrades it and allows you to reuse it? Is this kit includes some like enzyme within the material that breaks it down inherently? So it's not, we don't need extra infrastructure, it's just baked into the material. So there's a lot of different solutions, and I think a lot of people trying to address this. Yeah.
For the shape-changing ones, can it conform onto some objects that the plastic touches?
So the question was, for the shape-changing primitive, can it conform to the objects that touches it? The answer is yes, but also there are other types of substrates beyond the shape-changing primitive. It depends on what you're doing, and that,
If I want to make a dress that fits me perfectly,
yeah.
can I put it on me and put some
Yeah.
liquid and then it
Yes.
conforms to my
Theoretically, yes, but we haven't done that, so maybe we should collaborate. Yeah.
Also, out of curiosity, what is the cost of, say, even a small material or the liquid to put on the apple, or then in that case, a full-out crust at the top?
Yeah, that's a really good question. So the question is, what is the cost? And do you want to get this one? So this is related to our this like question of how do we make these materials, and also what is the right sourcing of them that allows it to be sustainable. And one of the sort of things that we want to do is sort of identify different waste streams and develop smart materials from that waste stream, so it can be practically free, because it's actually a waste product. For example, in our shape changing primitive, it's coming from a lot of like exoskeletons of like crustaceans, for example. So we can actually go to restaurants potentially and get all this raw, like lobster restaurant or different locations, and actually get all this material for free and process them. There's other costs, obviously, in processing them and stuff, and we haven't done that. Like, we haven't really gone to that level, but we're definitely working on that. Those are questions we're actively answering as we go.
So then, based on the cost of processing, either with a possible future of mass scale, do you think it would be affordable on a larger scale for clothing, or even in all the grocery stores?
I mean,
Okay, so the question was, would this be possible for mass production and to be cheap enough for people to actually experience in everyday life, in grocery stores and etc.?
Yeah, so as Verge mentioned, we're still yet to really do those calculations, but the materials are abundant and naturally occurring, and there are a lot of people working in similar spaces with similar materials and finding that it is feasible to mass produce them. And I mean, another part of our vision, that's part of why we're interested in the maker movement, is having these materials kind of upset mass production systems, which is another thing people are thinking about in terms of next economies, sustainable economies, and making these procedures available so people can say, in my town, in my neighborhood, in my coastal region, I have this lump of material and I don't want to have to buy wasteful plastics, so I'll locally create something that can serve my purpose, serve my community's purpose. And that's kind of a different way of thinking about production streams as well. It's not necessarily one person creating it, shipping it to the world. It's maybe you can actually create this for your city, for your town, for your family. So yeah, we're interested in exploring those futures as well.
So there are works about like artificial meat that basically, rather than killing animals, we can create cells that's going to turn into a steak potentially, or hamburger. Any ideas to get like some bacteria or microbes to grow up into a plastic bag, for example?
So the question was, there's precedent with people integrating bioengineering to create, for example, meat without the cow, and is there some sort of ambition that we have to just grow out a plastic bag from bacteria?
No, not the plastic, just the bag.
Oh, just a bag, just
From a
full on.
biomaterial that is
Yeah.
somehow
Yeah, I think that this is possible, and different people are working on things that are related to that. I think particularly our focus is built around there's a lot of waste products. There's a lot of organic waste products out there that I think we can utilize as a first step, because I think that is actually a further out future. And there might be different phases in this sort of new biotech world that may happen in the next 20 years. And I think the things that we're developing right now is possible right now. Not, we don't need like 5 years of research, 10 years of research to actually make it happen, I believe. So I think that's one aspect of it. And I think the other aspect is, I think synthetic biology is an extremely powerful tool. And I think there's lots of potential for us to create primitives around that. But right now we have different things that we're trying to focus on first before we arrive at, and also not really focus on one application specifically, but creating like a library or a platform around it. Yeah.
But the question specifically around biomaterials for bags or consumer use, there are a fair amount of people doing that now, creating fabrics. Yeah. But are you asking specifically to create the form?
Yeah, I mean,
Yeah.
basically to have some biological material that you can engineer it to grow in a certain
Shape?
shape
Yeah.
to meet specific
Yeah.
functionality.
Yeah.
Yes. There are definitely people working on that. And I think the
Making the steak, it will be good to have a bag. Very comfortable with it, and then you decide to eat it.
yeah.
The bag's gonna
Yeah.
The bag's gonna eat the steak. Yeah, I think one also thing I want to know about this, these bioplastics is that it's not alive. It's biologically derived material, but it's not alive. So you don't need to keep it alive in order to use them. So I guess the plastic would not eat the bag if it's using our bag. However, if you do grow it, that's a different conversation. Yeah.
And I think the problem with plastic is that it takes like millions of, I don't know, thousands of years to. I don't even know what exactly it turned into. So what is the technical term? But even, I mean, I won't be here in the same shape in 100 years, but parts of my body will still be here in a way. I mean, you can see like, bones of like people who were living thousands of years ago in caves and stuff. So even if it's biological material, some of it remains.
Yeah.
I think that's also the question is, I guess if I try to phrase it as a question, what's the difference between having a biological material breakdown versus a plastic material? Because do you want to
Probably
phrase it as a
that's-
question?
Maybe that's it. Yeah, it wasn't really a question, so I was thinking
Yeah.
out loud, like, yeah.
Right.
Yeah, I think different biological materials have different properties that have different lifespans. Bones have a longer lifespan than these bioplastics that we're using, much longer. And I think that's one of the challenges, and also one of the things that we're really excited about, which is tuning and tailoring very specific timescales based on the use,
Right.
and matching that with applications.
Right. Because I think a difference also is if you have just a plastic bag, it was kind of unintentional for them. It wasn't kind of a second thought for where they would go. It's like, okay, let's just put everything in the landfill, and it's kind of a single stream. And yeah, the materials weren't engineered with that in mind. But the difference is, how do you engineer an entire system that allows for these different kinds of degrading to happen and for them to go in the right place and to become regenerative, rather than creating stacks of material that's just sitting and emitting greenhouse gases or flooding the oceans.
Yeah, and contaminating the fish and other ecologies.
Right.
Thank you for this opportunity to speak with you guys. Oh, yeah, one more question. Okay.
Are those primitives or the agents that they respond to liquid? Do they have to be liquid? Are they always liquid, or can exposure to sunlight change?
So, Kitty had a question around, is the main input for making it change always liquid? So right now, the development of our work has been thus really connected to liquid because we were interested in interfacing with biological and chemical systems. However, that's possible. That's something we've actually been actively thinking about too, is what are the other inputs? Can it be based off of different, like temperature or UV ray or, different elements, or very specific compound exposure. So it's possible, and this is also why we want to build out this library. And I think these questions that you have are related to also that, like, what you can do with it and what scenarios. So I think this is exactly, yeah. If we find that that's actually something that people really want, is like a temperature responsive bioplastic, then I feel like maybe we can make that. Yeah. Yeah, thank you for having us here, and it's been really great to be able to speak with people about this and get your input.
I'll be sharing the video to more people. Some people in other sites, we have like artists in residency programs.
Okay.
I can share this.
Cool. Great,
Hello
awesome.
to anyone watching the video in the future. Feel free to reach out to us. Our emails are here. And please, if you can, fill out this survey. It's really helpful
Yeah.
to us.
Yeah, thank you so
Thank
much.
you.
And we have our cards here if you want to grab one.